Hi everyone, in this video I'm going to go through chapter 1.10 to 1.12. So our chapter 1.10 is about lines. So to start out, we're going to learn what slope is of a line. So slope m of a non-vertical line that passes through distinct points x1, y1, and x2, y2 is m equals rise over run, which is the change in y over the change in x. So this is going to be y2 minus y1 over x2 minus x1, where x2 minus x1 does not equal 0. And the slope of a vertical line is not defined. And our slope, that measured steepness from left to right, is independent of which 2 points are chosen on the line. So that means that depending on what point you choose, for certain parts of the graph, the slope may be different. So here's examples of like what looks like a positive slope, so it's going up to the right, negative slopes going up to the left, and then a zero slope is just straight across, so that's a horizontal line, and then no slope is straight up, and that's our m is undefined. So here we could see for our positive slope, we're rising, so this would be one of our points and one of our points. So we're rising up and running right. So it's always positive. Negative, we're rising, but then we're running to the left. So that's why it's negative. So we're going like back, left. Zero slope is because our x2s and y2s are different, but our y2s and our y1s are the same. So that's going to be 0 over x2 minus x1. Here, our x2 and our x1, it would all be the same. So that's why our slope is undefined, because it would be over 0. And then a way that I remember, like, is a horizontal line 0 slope, or is a vertical line no slope, or 0 slope, or whatever, is I remember because I remember because it has a O, which I think is like a 0. So that's how I remember which one has 0 slope. Alright, so for example, we're going to find the slope passing through points -3, -1, and -2, 4. So I always just start labeling which one's my x1 and which one's my x2, y2. So I'm just labeled those on top. So my m is y2 minus y1 over x2 minus x1. And that is 4 minus -1 over -2 minus -1, which ends up being 4 plus 1 over -2 plus 3, which is 5. This means, in words, that our slope 5, that means every unit we move right, so every 1 unit we move right, the line rises 5 units. So here's a graph of that. So our slope is 5, which that means really 5 over 1, with 5 being the rise and 1 being the run. So I rise 5 units, 1, 2, 3, 4, 5, and I run 1. So this is my x1, y1, and this is my x2, y2 points. So we have different forms of the equation of a line. So our first form is called point slope. So it's called point slope form of the equation of the line. So a non-vertical line with slope m that passes through the point x1, y1 is at y minus y1 equals m parentheses x minus x1. So we're going to do an example. We're going to find an equation of a line with slope 4 passing through -1, 3. And then we're going to solve for y and then graph it. So our y1 is 3. Our x1 is -1. And then our slope m is 4. So I'm going to just go ahead and plug these into our equation. So we get y minus 3 equals 4 parentheses x minus -1. So remember not to plug our y1 and x1 into these ones. We just leave those. We're plugging them into the other ones. So I get y minus 3 equals 4, x plus 1. And then I distribute the 4. And then I'm going to solve for y. I get y equals 4x plus 7. And we see our slope's 4. So that's good. So I'm going to go ahead and I plotted here -1. So I went -1 and then 3. So I plotted that one. And then my slope was 4. So I went up 4, 1, 2, 3, 4. Then I went across 1. Let's actually do this one together so you guys can see. Okay, so I have -1, 1, 2, 3. So I have my point there. 1, 2, 3, 4. Alright, so I go up 4, 1, 2, 3, 4. I run 1. And then in order to get the down one, like a point somewhere over here in the bottom, 4 over 1 is the same thing as -4 over -1. So now I'm going to rise -4, which is going to be 1, 2, 3, 4, and then run -1. So I'm going to go -1. Then we draw our line through our points. Okay. Now we're going to find an equation of a line through the points 4, -3, and -2, 6. So first, we're gonna use point slope form. But we need to find our slope. That's something that we don't have that we had in the last question. So we solve for our slope. So I just have x1, y1, x2, y2. So I solve for my slope. My slope is -3 over 2. And then for our point slope form, you could take either point for -3 or -2, 6 as your x1, y1. So I'm just going to go ahead and use 4, -3. Usually try to choose the easier one. So I have y minus -3 equals -3, 2, x minus 4. I solve for y, and I get y equals -3 over 2x plus 3. So that was point slope form. So another form is slope intercept form. So the line intersects the y-axis at a point 0b. So b is our y-intercept and m is our slope. So with y equals b and x equals 0, we plug that into like our point slope form. So this is like point slope. So our slope intercept is derived from point slope. And then we get y equals mx plus b. So the slope intercept form of non-vertical line with slope m and y-intercept b is y equals mx plus b. So an example is this. We're going to find an equation of the line with slope 3 and y-intercept -2. So our m is 3 and then our b is -2, and we just plug those in. So y equals 3x minus 2. And then an example, we're going to graph f of x equals -3 over 2x plus 2. So the first thing I do is I'm going to graph my y-intercept. So my y-intercept is 2. That means I go up. I don't move anywhere on the x, and I just go up 2, 1, 2. So there's my y-intercept, b. Alright, and then my slope is -3, 2. That means I go down -3 and then right 2. So I go 1, 2, 3, 1, 2. That's my other point. And then I connect the dots. Let's see what would happen. So our slope was -3 over 2. Would it matter if I did 3, -2? Sorry, rise 3. 1, 2, 3. And then I go left 2. 1, 2. So that gives me a point up there. So you could do it either way. The negative could either go on the top or it could go on the bottom. Okay, vertical and horizontal lines. So we've seen some of this before. So our equation of a horizontal line, so a horizontal line is given by the form y equals b, where b is the y-intercept and the slope is 0. So we can see that because if we're going horizontal, it's just going to basically be the same y value the whole time, which is the b. So that's why it's y equals b. The equation of a vertical line is given by an equation in the form x equals a, where a is the x-intercept and the slope is undefined. So we can see here in our picture, x equals a. I'm going to take that out so you don't think it's a horizontal line. But we have the same x value the whole time. That's why it's x equals a. Okay, so some examples of how we're going to graph this. So y equals -4. We choose a bunch of different x values. Whenever we plug in, there's not really a place to plug in the x. So it's always going to be -4. So then we just draw our lines with all of our points. So for x equals 2, x is always going to equal 2, and then we do a bunch of different y values, but our x is always going to equal 2. So we do our different points, and then we make our line. So we also have a general equation of a line. So every line has an equation that can be written in general form. ax plus by plus c equals 0, where a, b, and c are an r, and a and b are not equal to 0. Okay, so we're going to use intercepts to graph ax plus by plus c. So we're going to find the x-intercept, plot, find the y-intercept, and then plot. So we're going to graph 4x minus 3y minus 6 equals 0. Okay, so to find the x-intercept, we plug in 0 for y. So we get 4x minus 6 equals 0. And then our x is 3 over 2. So that is our x-intercept. We go ahead and graph that. It's right here. Oh, oops. I'm going to draw my things here. Okay. And then we're going to find the y-intercept. So we plug in 0 for x, and then we get -3y equals 6. So our y is -2. So that's our y-intercept. So I go ahead and graph that. That's 0, -2 right here. And then I just connect the dots. Or if we wanted to, without doing the intercepts, we could just write this equation in slope-intercept form and then graph it as well, doing slope and y-intercepts. Okay, parallel and perpendicular lines. So two non-vertical lines are parallel if this IFF, that means if and only if. So I'll write that. They have the same slope. So two distinct vertical lines, both with undefined slope, are parallel. So basically any vertical lines you have, if they're distinct, they're going to be parallel. Okay, so for example, we're going to write an equation of a line passing through -3, 1, and parallel to the line whose equation is y equals 2x plus 1. Okay, so we know our x1 is -3 and our y1 is 1. So we plug those into our point slope formula and we get y minus 1 equals m parentheses x minus -3. So we're missing our slope. So where do you think our slope is going to come from? So since it has to be parallel to y equals 2x plus 1, they have to have the same slope. Therefore, our m is going to equal 2. So we go ahead and plug that in. And there's our equation of a line. And we don't have to really simplify it. It just wants the equation. All right, two lines. So here's a perpendicular. Two lines with slopes m1 and m2 are perpendicular if and only if m1 times m2 equals -1. So our slopes are negative reciprocals of each other. So M2 slope is going to be perpendicular to a line if it has a -1 over M1 slope. So a horizontal line of slope 0 is perpendicular to a vertical line of no or undefined slope. So for example, we're going to find an equation of a line passing through 3, -5 and perpendicular to the line whose equation is x plus 4y minus 8 equals 0. So we have x1 equals 3 and our y1 equals -5. So we plug those into our point slope form and we want to find our m. So since it has to be perpendicular to the line whose equation is this, we want to find the slope of this line to get our m. So we go ahead and get y by itself, and then we get y equals -1 over 4x plus 2. So our m for here is -1 over 4. So a line perpendicular to that line is going to have an opposite and reciprocal slope. So by opposite, we mean opposite sign. So the opposite sign of -1/4 is 1/4. And then reciprocal is you flip the fraction. So we get 4 over 1. So our m equals 4. So we go ahead and plug 4 into our point slope formula. Okay. And then here's a word problem that we're going to use our equations for. So for example, a pool is being filled with a hose. The water depth, y, in feet in the pool, t hours after the hose is turned on, is given by y equals 1.5 t plus 2. So what do the slope and y-intercept represent? So we know our slope is m equals 1.5 and our y-intercept is 2. So the slope represents an increase in 1.5 feet in water depth every hour because it's really 1.5 over 1. So the 1.5 is our increase in water depth feet per hour, really. And then the y-intercept indicates the water depth was 2 feet at the time the hose was turned on. And that's because our y-intercept, I'm going to do it over here, is 2. And then from there, we're adding 1.5 t. So it started at 2, and then every hour it increases by 1.5. So it keeps going up 1.5 t. So that's our line. So it's added from 2. Alright, I'm going to go ahead and end the video there, and then I'll continue the next video with sections 1.11 and 1.12.